Okay, page 210. Okay, example 6. Okay. Example 6. Okay, look at this question. Simple pendulum. The question gives you two different heights, 0.1 and 0.05. And look at the question. Okay, this part. Lowest position should be this part. Okay, and it is then released. Okay, it means that 0.1 meter you release it. So this one tells us that when you release it, this one, the initial U should be 0. It means that KE should be 0. Okay, then this one should be the highest position. 0.05 is not the highest position. This ball may move up or move down, depends on the situation. Now keep going. Look at the question. Find the speed of the ball when it passes the lowest position. Because this one is the highest position, all the energy should be coming from PE. Then PE at that time should be the maximum. KE will be 0. This one implies that ME, the total energy, total mechanical energy, should be the maximum PE. Okay, and all the energy will be converted into KE because at the lowest position, PE will be 0. So look at this. You should find out the total initial energy. Total initial energy include initial KE and also includes initial PE. Final KE and final PE. This one should be the KE, the PE maximum, KE minimum. This one KE maximum, PE minimum. Then you can find out this result. Of course, in examination, I suggest you to put it negative 1.4. But finally, what is the final answer? If the question asks you speed, they are the same. But if the question asks you what happened, you should say that this one go to the lowest point, maybe move towards the right hand side or move towards left hand side. Depends on the situation. And also this this solution tells us that M will cancel each other. So this one tells us that does not depend on its mass. Part B. How about the 0.05 meter measured from the lowest point? The same. Total initial energy, and this one is 0.0 meter. We have PE, but this one is not the maximum. We also have KE, this one is not 0. Then for the calculation, we can find out V, the same, can be negative. Positive may be go up, negative will be going down, like that. Okay, that's all for this. Okay, next case. Trampoline. 跳彈床. Okay, then in this case, what happened? In this case, we have 3 different types of energy. We have the elastic potential energy. First of all, you should know that what's the elastic potential energy. Initial case will be the lateral length of the string. In this case, EPE will be 0. But when you extend it, 延長, then in this case, EPE will be increased. If this one is not a string, if this one is a spring, like that, under a compression, EPE will also be increased, like that. Okay. In this situation, because this boy may have the weight to let it to extend, it will absorb EPE, elastic potential energy. And also, in order to simplify the case, the lowest point, okay, the lowest point, we say that this level will be GPE will be 0. And also, this boy, keep it here, low change, low speed, KE will be 0. So, everything, all the energy should be EPE. Now, jumping up, what will happen? EPE, the string will go back to the original position. EPE will be 0. And how about the boy? The boy will move up a certain height. GPE will not be 0. And also, all the energy will give it to KE, a part of GPE. Then KE will be like that. Go to the highest position, KE will be 0, GPE will be the maximum, EPE is 0. Go to the highest position and then come back like that, okay? It will absorb back the energy. It means that the kinetic energy and also the GPE, because you can see that the GPE is losing, KE is losing, EPE is increasing. Summary will be like that. Example 7. Okay, example 7. Bungee jump. Look at the question. At the beginning of the jump, becomes momentarily at rest at position A. Okay. After falling for a certain distance, start to pull by the cord 嗰條橡筋繩 at position B. So at that time, you should draw the diagram. Initial point A, the string should be loosened until position B. This one will be the length of the string B, and starts to slow down because this one will provide upward tension to make it balance to the weight. Finally, this one reached the point C and then becomes momentarily at rest again at point D. Okay, so this one C, when it reaches position C, C will be the lowest position, and then this one will come back to a certain position D. Okay, now next part, what happened? At which position does the jumper have the lowest KE? Lowest KE means that momentarily at rest. So your answer should be D, of course, because the question tells you already, and also A, this one, because the velocity is 0. Next, GPE. GPE will be the lowest. It means that the lowest position. The lowest position of it should be D. Okay, lowest position should be D. Oh, okay. So this one, the D should be here. Okay, D will be the lowest point. A, B, C, D should be like that. I will explain it later. B and C. And EPE is the lowest one. Of course, should be A, because the string haven't any extension. B also, but after B, look at the question, starts to be put by the clock at position B. So it means that from B to C and to D, the string is under tension. Okay, part B. At which position does the jumper has the highest KE, GPE, and EPE? Go back to here. Highest KE. It means that the velocity should be the largest one. The largest one should be this one. Starts to slow down. Okay, it means that the maximum speed should be C. Okay, the answer should be C. How about second one? Second one will be the GPE. GPE will be the maximum. It means that the highest position, A. EPE. It means that the extension, okay, should be the largest one, D. Okay, this one for part B. How about part C? Describe the energy change from A to B, B to C, and C to D. So look at this. A to B. From A to B, you can see that PE is decreasing from highest point A to lower point B. GPE is decreasing. Decreasing for what? For the increase in kinetic energy. But how about EPE? Because the string is not the string haven't any extension, so EPE should keep 0. Second part, from B to C. From B to C, GPE of the jumper is decreasing, converted into kinetic energy. And also, because the string is under tension, EPE is also increasing. Part C, from C to D. Okay, GPE is also decreasing because higher point will be C, lower point will be D. KE is decreasing because the question tells you that slow down. It means that the speed is smaller and smaller. KE is smaller and smaller. If all the energy will be converted into EPE, EPE is increasing in this case. Okay, final answer will be like that. How about this? If air resistance is not negligible, 唔可以避免, would the lowest position of the jumper be higher than, equal to, or lower than before? You should look at this. If we have the air resistance, it means that we have energy loss. Energy loss to overcome air resistance. Then less EPE is stored in the core. Okay, because some energy is used for against air resistance. Then what happens? Its lowest position will be higher than before. It means that it cannot reach the original or expected lowest position.